Hello, everyone. This is Alex Volkov. I'm a AI evangelist with Weights and Biases, and this is ThursdAI Special Sunday episode. Some podcasts call those just episodes because that's what they do. They have a conversation. It's an interview with interesting people, bringing you interesting ideas. But on ThursdAI, you get the news every Thursday, everything about AI. And sometimes on Sundays, you get deeper dives. And those deeper dives can vary. Sometimes those are just conversations we've recorded during our live show taping on X. And if you never joined those, more than 1,000 people join every week on the X Spaces platform. So you're more than welcome to experience that and ask questions in real time. And sometimes those conversations are ones I record with guests offline, like the one that I'm going to bring you soon, which is a little teaser. It's a very interesting and unique one with Alex Zhadan and his new fiancée, Karina, from Moscow, Russia, who've met after Alex built a chatbot that auto-swiped and matched him with more than 5,200 women on Tinder, including Karina. And then as they met and kept dating, the bot also suggested tips for their relationship. It's a very interesting conversation that we had. And so I'm going to bring you that one. And that one was recorded asynchronously, unlike some of the other stuff. But this week, I'm bringing you two guests, or I guess three guests, but two conversations. And before I tell you who those guests are, I will say this thing. This weekend is the Apple Vision Pro weekend. And I personally, right now, I'm recording while watching multiple screens floating in my actual space. And that's been incredible to try and tinker with. And while this is an AI podcast and newsletter, and I have yet to find a connecting link here between this technology leap and AI's technology leaps, and don't get me started on Siri. I'll definitely be covering my experience on the next ThursdAI because I love everything new and technological. AI is a huge part of it, but it's not the only part. And given the recent suggestions on the Apple finance call, Tim Cook hinted that AI is coming to Apple. And it's about time. Apple usually takes its time, like with the VR headsets, but also with AI. And it's about time that they will release something. We'll definitely cover that. And I think some of this will be spatial. Okay, back to the matter at hand. This deep dive is all about datasets. If you've used or fine-tuned or trained or heard about an AI model, you may or may not realize how important the dataset that the model was trained with. We often talk about this model, that model, and often the only difference is which additional data that folks have collected, curated, and structured have fine-tuned this model on top of. And so we often see different models that are basically the same, what's called pre-training. They're fine-tuned on top of different ways to help the model learn, right? And creating and curating and editing those datasets is like an art and a science. And so if you've been listening to ThursdAI for a while, you know that many of the folks who fine-tune the best models around, folks like LDJ, who's a frequent co-host here on ThursdAI with the Capybara dataset, folks who are like Alignment Labs with the OpenChat, and of course Technium with the Hermes from News Research. Folks like these have been consistently taking off-the-shelf open source models, for example, Mistral or Yi34B, etc., and just make them smarter or more instruction fine-tuned or more specifically better for specific purposes using those datasets that they've created and curated. And those datasets are paired with different techniques as well. For example, we've talked about the so-called DPO, which stands for direct preference optimization, which is a technique that shows a lot of promise lately, since it's not only showing a model or LLM in training, a baby LLM, if you will, what is the right answer to each question. It also shows an incorrect answer as well. It's been proven that this helps with some cognition and answers, possibly even role play, I guess it's called. And we had a conversation with John Durbin, one also a friend of the pod and a curator of the greatest datasets around, that talks about how this affects the models. However, the problem there is, and genius of these folks stands in the fact that they can wrangle thousands to hundred thousands to millions of rows of text into something that a fine-tuning process can handle. And often, and this is why I'm taking my time to explain this to you, and often this work is the process of creating a better model. These datasets can range from super high quality 16,000 rows, like in the case of LDJ's Capybara dataset, to millions of rows. Technium previously released, this week we've talked about this, he open sourced Hermes 2.5, which many very great models used, and that's almost exactly 1 million rows. Oftentimes, they are an amalgamation of different other datasets into one. So in case of Technium, he used, for example, the Ouroboros dataset from John Durbin. He also used the Platypus dataset from the folks at GarageBand, an interview with whom we had in the summer. And if that's interesting to you, definitely check that out. And he also used the shared GPT dataset from LMSys. So all of these datasets separately, he arranged them into this one big one, and he curated. That's the curation part. And it's really hard to wrangle all of this. It's a lot of code, etc. And when Technium released his Hermes dataset, he also added the link and said this dataset also exists on the Lilac website. And I have met with Nikhil during Neuro IPS, and I definitely wanted to bring him on because they're building an open source dataset visualization and classification engine called Lilac. And that tool is indispensable in trying to understand these millions of potential text rows. And so I wanted to bring those folks and talk about the whole problem, how they got here, why they chose open source, and what they recently announced. And this is the conversation. So we had Nikhil Therat and Daniel Smilkov, who both met in Google and work on TensorFlow.js and another see your data tool inside Google, and then left and built Lilac. And also their new thing called Lilac Garden, which is a web service for you to run these classifications faster. And I think it was very cool because not only do we have Nikhil and Daniel on stage, we also had Alignment Lab and LDJ folks who build datasets, curate them, but also use Lilac. And Technium was in the audience. He doesn't often love to come up and talk, but he was sending like a thumbs up all the time because he also stands by Lilac as one of the greatest tools that he uses for this. And as the guys were talking, I was browsing to the Hermes dataset and the OpenOrca dataset. It's even bigger. OpenOrca is around 4 million rows on the visualization platform of Lilac that, by the way, lives on the Hugging Face. And in the show notes, you'll get a link to that and an image as well. So check out the newsletter. And you can literally see that it's categorizing by embedding and doing a bunch of other classification stuff. You'll hear Nikhil and Daniel talk about them. It's categorizing all these huge datasets, and you can zoom in to the 912 rows that talk about movie reviews from the movie in field category, or the 364 rows that answer movie plot questions in the movie questions category, right? And so you can just like zoom in and out and definitely take some pieces out or pieces in. In the case of Technium, where he did an amalgamation of multiple datasets, you can also see which sources of data sets, and you can browse this data very easily. So a great tool, and I wanted to bring this to you because it's a very big piece of the creation of these better models, and the better folks like you who listen to this podcast know how to use these tools, the better models will get. And also to highlight how important data sets and information that these tools learn is. And the second part of this conversation is a conversation with Eugene, who goes by the handle Pico Creator, who is in charge of the RWKV project and architecture. RWKV is one architecture that tries to show that a alternative to transformers is possible, and transformers are amazing. We've all seen the latest rise in generative AI, which is largely attributed to the Transformers paper, aka Attention is All You Need, back from 2019, I want to say 2018 from Google. And RWKV is another type of architecture, RNN, that tries to get the same performance without the fallbacks of transformers. Transformers are notoriously suffering from something called quadratic attention problem, where the more you ask of a transformer to pay attention to text, the hardware requirements for that grow in the quadratic state. So this means that the more context you have or the more text you're training, the stronger are the hardware requirements. And RWKV is one attempt at solving this. We've previously covered Striped Hyena and Mamba, which is the state space model architectures that try to solve that as well. And here we had the chance to talk about RWKV5, aka Eagle, which is a model they released around 7 billion parameters. And the creator of this, the Pico creator of this, if you will, Eugene, gave us a little bit of a deep dive. So that's part 2 of this podcast. I really hope you enjoyed this conversation first with Nikhil and Daniel from Lilac, and second with Eugene. And definitely stay tuned for the exciting conversation with Sasha and Karina next in probably one of the next episodes. With that, I give you ThursdAI on a Sunday special deep dive. So Nikhil, welcome. I think this is your first time on the space, but we met in NeurIPS, right? One of the parties, I think, for Mistral. And then since then, I've been saying, hey, we need to chat about datasets. We need to bring some folks here on stage. Feel free to unmute yourself and introduce yourself, and then we're going to talk about Lilac.
Hey, Alex. Good to be here. So Nikhil here. Daniel's actually on the call with me. So we are working on Lilac, right? It's a startup that we co-founded last year in April, and we're focusing on data quality for AI systems, both on the understanding side and the sort of LLM-powered curation side. And yeah, we met at the party at NeurIPS, and I think you invited me just because I was being ridiculous and nothing about AI. So
I heard about Lilac before, and I wanted to see why the folks who work on these data sets even mention Lilac. So can you give a brief intro of Lilac, before the new stuff? Can you just briefly introduce the concept? What are you guys doing? Why are you doing it? And what does it help in any way to build data sets like we just talked about from folks like Alignment Labs here on stage, Luigi, and folks like Technium?
Yeah, so I'll give you a 1-minute history a little bit. So before this project, Daniel and I were at Google for a while, and we worked on TensorFlow.js. So we worked on sort of machine learning algorithms for a while. That was a blast, but then we had this sort of obvious realization that data quality really is the thing that's going to drive progress here. And so we actually worked on something that looked like Lilac inside of Google called Know Your Data. And this is before the sort of generative era. So we worked on this in the context classification models. And so we were like, okay, look, let's just throw all of these classifiers at data, and then we can think about it as if it was structured data. And that's the approach we took inside of Google. But Google had all of these amazing classifiers that they had for search indexing. And so when we decided to leave and start a spin-off of this outside of Google, we were like, holy crap, how are we going to find, classifiers? And that actually coincided with this era of foundational models and LLMs and so on and so forth. So all of a sudden, you can actually have a lot more flexible on-device classifiers that are very simple to build that immediately enable us to do something like this. And so that was really cool. And so the goal for the project is to build this in the open source, because folks at Google, when we were building Know Your Data, were like, can we get the open source version of this? So that's a very important piece of this, because that, to me, is what's going to drive progress in this space. The idea here is...
Could you define classifiers for folks who have no idea what we're talking about? Is this like a specific model that says one thing is one thing, another thing? And how does this relate to embedding concepts and seeing what they represent just from an embedding purpose?
So at Google, a classifier just means you take something, maybe it's a document or an image, and you make a prediction of one of 10 classes, right? So maybe in an image, you have a classifier that can predict this is a dog or this is a cat, right? It's not generative in the sense that we're not making pixels of a cat or a dog. We're just saying, yes, you're in A or B, right? So that was the idea there. There were teams for each of those classifiers at Google, which is why it was incredible, right? And what we've done in the sort of open source world to build classifiers is use embeddings, right? And so what we do in Lilac is we compute embeddings over your whole data set, which is about 90% of the work of understanding the content. And then we let you train little classifiers on device on top of embeddings that let you customize that classifier for whatever you want. So I could find documents that are refusal of service by a language model, meaning as a language model, I cannot do X. By just showing you examples, a few examples of as a language model, I can, and then some random other example. And so that's how we've taken advantage of LLMs to do this type of analytics work. And that's where we started, right? And then very quickly, what's happened is people are like, great, I found all these issues in my data set. Now what? Like, how do I actually fix the problems in them? And we're like, oh, why don't you go on an IPython notebook and do something upstream? And so the second phase of the focus for the company is really just like, how do we actually curate the data inside of the tool? How do we remove things? How do we transform things? How do we actually understand the diffs after we've made a heuristic change, right? And so a lot of the ways I like to think of this is a lot of the folks in this room are doing lots of bespoke magic voodoo, like that you just said.
Yep,
and
alchemy,
they say,
yes.
Python, it's alchemy. It really is. And we are trying to somehow make this into a little bit more of a science than an art in a way. Can we productize some of this? And for folks who are new to AI, can we take some of these techniques and build them into a product? So that's some of the things that we're trying to do.
Just to summarize, Google has for the longest time built specific teams for specific classifiers for specific topics. The whole transformer explosion, generative AI, whatever, changed the game a little bit because these are now general classifiers. Is that correct? And then you're using these new technologies together with your expertise from there to actually give folks tools to run through these data sets, classify them into different things, and then also find out specific things that they want without building a specific classifier or but with your platform. Let's talk about the recent news then. Let's talk about Garden. So you recently announced an announcement. This is why I wanted to finally connect with you and bring you here. And in this announcement, you host a bunch of data sets on what seems to be the most impressive Hugging Face space ever, because it doesn't look like Gradio. And you host those data sets and folks can actually go and see classified chunks of the data set. Could you talk about Garden, please?
Hey, so great. So I'm going to let Daniel take this one because we're on the call.
Hi, I'm Daniel. Nice to meet you. Yeah, I've been working with Nikhil very closely at Google for 7 years out of my 9 years at Google. So we basically pair program, but actually not anymore actually pair program, but pair work together a lot, almost like a one brain, but we're a little different. So when we are together, I feel like it's much more productive. So that's a quick intro. And then for Lilac Garden, so actually to back up a little bit, clustering has always been on our roadmap. People have been asking us to do clustering so they can understand the data. And clustering is a little tricky because it has a lot of hyperparameters, knobs you have to tune. And then also, let's say you get these cluster integer numbers, and then you have to go browse them. So what needs to happen is to get a really good experience of understanding your data. You not only need to polish the clustering side with all the algorithms and hyperparams, but also have a UI where you can explore those clusters. Because just giving people integers is still not going to solve the problem. Sometimes giving them a 2D plot is good, but it's not very detailed and you can lose a lot of context and you can't curate with precision. And so what happened is we're building the Lilac UI. We felt like we were in a good place where we can actually show you clusters and groups. And then we were like, let's now do clustering. And we implemented the clustering code fully open source. But what happened is it's very slow on a machine. And we tried to make it as fast as possible, push the limits of what a MacBook can do. Let's get it to be really fast, use small embedding models, like 30 million per app models, and do that. And it still didn't scale. And this is where we were like, hey, what if we just start building the cloud solution for this, where you don't have to deal with 5 gigabyte CUDA dependencies, just so that you can run QML and HTTP scan with CUDA kernels, these are the clustering algorithms. And so we did that, and we realized that you can cluster stuff in 10 minutes. And because you can cluster stuff in 10 minutes, we started clustering everything. It became like this thing where the way we manipulate data changed, even in Lilac. We're not thinking twice before saying, oh, should we index this data set and compute embeddings? Yeah, sure, press a button. In 3 minutes, you're going to get something. Well, it costs $1. It's okay. And I feel like that kind of completely changed how we think about it. Whereas before, we were always because everything ran locally, we were before a big meeting where we have to demo something, I was like, Nikhil, did you pre-cluster it? Oh no, shit, I forgot. I had to go. And then it was all this stress of, oh man, it's going to take an hour. Why didn't we prepare for this meeting? No longer that. I think cloud changed how we think about this in a big way.
So just a follow-up here for folks who don't visualize and didn't click the link. For something like the Hermes dataset or the Capybara dataset, clustering means just there's millions of rows potentially, thousands to millions of rows of what's basically instructions for these models to then fine-tune, to learn from, right? What the user would say and I think the Hermes dataset is built with the shared GPT instruction, JSON, what the user would say, and a whole conversation, right? So imagine a structured conversation, and that's thousands, if not millions, if not whatever, of rows. And then how do you know which conversations talk about what? That's what you mean by clustering, right? So being able to pinpoint, let's say, in the which of these conversations talk about programming or code. And then out of those, which conversations actually and how much a percentage of talks about assembly or Python. Is that a fair representation of what you mean by clustering?
Yes, that is it. That is it. Clustering is a way to summarize the data set in the way humans think. And the way humans think is they think like high level, this data set might have math and physics and it might have some poetry. And then humans are also capable to say, okay, not only does it have math, it has linear algebra, and it has also fifth grade math, and it has high level complex geometry topic. And so we wanted to, with our clustering, achieve the same experience that people think mentally when they look at data. And that is, we actually have in Lilac Garden 2 levels of clustering. We do give you a high level topic view, and then each topic has a more fine-grained cluster. And then the thing that made clustering much more interesting after LLMs is even in these like fine-grained detailed clusters, they might still be like 1,000 data points. And it's actually, text is really hard to read, unlike images. Like with images, when we were clustering images in Google, I could show you 3 images and you'll be like, that's a cluster of a dog. I get it. It's much less pleasant to show you 3 entire documents of linear algebra to be like, hey, that's a cluster of linear algebra. So what we do now is we use LLMs to title the clusters.
Mm-hmm.
And LLMs are really good at summarizing clusters. And they're actually, maybe that's like the primary thing that they do is they're really good at finding the vocab, the words to express something. And they can be even better. I believe that they can be better titlers than us humans if prompted correctly. And I think that titling made this experience a lot more interesting. We also have a search box in our demo. And when you search in cluster view, you can search over these titles, which is actually also a lot more pleasant than searching keywords. Because in a keyword, you're going to get a random document. But if you start searching in title across these auto-generated titles, you get a much more interesting experience understanding your data.
Awesome. So we're lucky here that we're joined on stage by folks who you actually featured in Garden, data sets of whom you embedded and clustered as well. So I want to turn the attention to some of those folks and ask, how does something like Lilac help? So Alignment Labs, feel free to unmute and chime in here, and LDJ after that as well, because definitely the Capybara and the Hermes dataset that we mentioned before, OpenOrca and the Capybara, all data are all clustered in Lilac there. Do you guys want to share what's your experience of like after building these data sets, generally just in text, now seeing this and being able to cluster? How does this help?
It's a big deal. So one thing that people don't really think about when they're out of the workflow is when you have a data set that's 10,000 or 100,000 or like 1 million examples, like you can't go through it. It's not an amount of data that a human can look at every single example. And so like visualization and clustering tools are gigantic.
I'm just looking at OpenOrca right on the Lilac Garden intro, by the way. It's like 4,200,000 rows, right? On the OpenOrca dataset. It's ridiculous.
Yeah, no, I really wish we had Lilac when we were making it. It was very much the dark ages, I think, prior to that. Having a UI on the front of anything in machine learning, I feel like is gigantic. It's like something that everything is sorely lacking. So having it right on the front of just the data science part, which is the most, to me, it's the most unintuitive and the first kind of wall you hit when you're doing any of this stuff. I think specifically with Lilac has been really big there for my own workflow because it just lets me automate so much and not have to manually go through and pick random samples and hope I'm hitting it right, or otherwise build giant pipelines for every single data set.
Incredible. And LDJ, I want to hear from you as well because Capybara is featured there. 16,000 rows. Have you found any different sites from this? It's still 16,000 rows. It's like an incredible amount of text to read for a human. Have you found the insights after watching your dataset being gardened or whatever you guys call it?
Yeah, it's definitely interesting. Through a lot of regular clustering, I usually wouldn't see I did try and put an emphasis on things that show good demonstrations of critical thinking and things like that within Capybara. And it's good to see Lilac Garden is actually able to show me that is actually there. It even shows the breakdown of, it shows this, I think it shows at least 10% or 15% or something can roughly be labeled as critical thinking. And then it shows the further breakdown of how those look like within that. And yeah, I think it's already giving insights that could help improve how we end up making, or at least how I end up making my next generation of data sets. Yeah.
So Nikhil, Daniel, Lila Garden is out. You guys start seeing that, okay, you can offer a cloud service for this that people can use and then not even think about this. It's still possible locally if people are like super GPU poor and money poor as well. Would they be able to run the tools that you have and just leave for, I don't know, a week and back and then the full data set is clustered?
Oh, yeah, definitely. Everything's open source, right? So you can absolutely run this on your device. If you have a CUDA-enabled machine, go for it. That is perfectly acceptable. I will say, I'll give you some of the numbers. So for Capybara on Garden, which is our cloud endpoint, it's like actually just a minute. It's like a minute, something like that, 90 seconds. And then
for
on
the 16,000, right?
Yeah, for 16,000. And then on the larger data set side, let's take OpenHermes or OpenOrca. OpenHermes is a little less than 20 minutes now, which is crazy. If you run this on your device, it's like 100x slower, which is what, 12 to 24 hours.
We've never finished. So like we tried a million data points data set. It just never finished clustering. The slowest step is the UMAP. UMAP is like dimensionality reduction technique that actually can make clusters more pronounced. And it just never finished. But
on
I'd
a
say
Mac, on our Mac
on a
M2.
Mac.
I think if you have a GPU.
But it's also a little counterintuitive. Clustering feels like quadratic a little bit in the sense that like for 10,000 points on your laptop, it might actually finish in like 15 minutes. So actually, if you have 10,000 points, totally run it locally. But then don't be surprised that if you go from 10,000 to 100,000, it might take hours. Right. And then from 100,000 to a million, it will take 24 hours.
And just a sneak peek at some future stuff that we're thinking about, it turns out
Yes,
that
please.
if you have huge pre-training data, what you could do is subsample down to something like 1 million to 5 million. Then we compute clusters. And then out of HTTP scan, you get this way to basically soft classify other points. So very cheaply, you could actually subsample a huge data set, get your classifier, and then run that for the rest. And now you've actually clustered up to 1 billion documents in some reasonable amount of time. So that's something we're thinking about for our other folks that are in the pre-training phase. And I think going beyond just understanding data, right? So like clustering historically is like, okay, I have a sense for the shape of my data. But now what's cool is inside of the tool, you can use it to focus your curation. And for example, like we found in a function calling data set, like 7% of the data set is the model asking about pizza, or sorry, a user asking order about pizza and the model saying, no, I cannot, I don't know about that function, or I'm an AI. And this is 7% of a 100K document data set. And so and this is being used all over the place. So you're just wasting compute all the time, right? And then the other thing we're going to do soon is, can we make clusters stable over time when you have version 2 of a data set?
That was my next question. Like, how does this, because in my head, okay, this is one way to like, one thing to visualize what I already have or an existing thing to figure out which parts to take if folks are doing alchemy and combining data sets, right? Completely another is like continuing working on this data set, adding more examples, trying to tweak some things in a data set, not hyperparameters, but definitely more or less of this or that, just to see results. And this is also some part of the alchemy that you're trying to make a science, not an art. So how are you going to attack this, or how it already helps?
Right. And there's still going to be a part that is an art, right? We're just trying to make it a little bit easier and have more eyes on it, right? Some of the things that you might want to do are like, maybe this cluster that I see is underrepresented, and I can go expand that cluster out by creating synthetic data, right? That's another way that you could do this when you see a small cluster. When I was talking about the data over time thing, the idea would be we haven't done this yet, but we have ideas of how to do it, where you make clusters consistent over time, where new points come in and they can either get assigned to clusters or they're stable enough that we can diff data sets at the cluster level. So instead of diffing at some other feature, we can say, how did the distribution of translation change between version 1 and version 2? And is that what I expect, right? So that's one thing that we're thinking about, implementation details aside. One way that we could do that is in Lilac, there's kind of 2 pieces of classification right now. You can think of one as on the concept side. So concepts are a very manual way to go collect data in a classifier and then be able to apply that to a data set and understand how it's distributed. clustering is this automatic way of almost finding these concepts for you. And so one idea here is actually promote those clusters into concepts in such a way that I can track those over time. It's almost like checking the clusters in so that I can see how that data evolves over time.
Oh, wow. That's quite incredible. I want to quickly follow up, Nikhil, before we conclude this conversation. Two things that I noticed inside the garden stuff. There's a RAG thing that I can't work with. It doesn't working. Could you talk to me about the retrieval augmented generation piece of this? And also in the settings, there's a bunch of ways to choose preferred embeddings, and you feature there GTE small and base, Gina, the folks we've talked with Gina embeddings as well, OpenAI, which obviously many people use here. So talk to me about preferred embeddings first. What's the purpose of this drop down, and are you supporting kind of the latest and greatest? And then let's talk about the RAG stuff.
Yeah, so we'll start with embeddings. We're going to keep adding embeddings as they come out. We tried to make the API simple enough where you can register your own embedding with a few lines of code, and you can actually load embeddings now that are pre-computed elsewhere. The idea was originally that there's so many embeddings that people should just do it on their own. I think the reality is we'll have to be like LangChain, where we just implement them all, which is how they were pretty successful. So the preferred embedding just means I know I want to use OpenAI embedding, so just make that my setting. Or I don't want to send my data to OpenAI, so use some on-device model. Or I don't care about multilingual embedding, so I'm going to use some smaller embedding. So you just set that once and you forget it. That was the original idea. But I think we're going to keep adding them as they come, especially after today's announcements. So that's on the embedding side. So RAG, this is funny. We had this realization that what we're actually doing is we are a fancy retrieval mechanism, right? Lilac is indexing your data in ways that are both from Python functions or from embeddings, and then with concepts, and now with clusters, right? That's fundamentally what we're doing. And then we have a powerful retrieval engine that sort of sits on top that lets you ask things like, give me the rows that are in a certain cluster and sort by their membership score. And I don't want anything that has, as a language model, I can do X in that. And then I want to take that and I want to sample from it, right? That's what we built to power the actual UI. And the realization was, wait a second, that's just the R of a RAG, and that's the hard part of a RAG. So we're started to prototype this way of saying, can we just use the retrieval engine inside of Lilac to both power the RAG, but also as a visual interface to that RAG, right? I actually want to be able to see the results as they get retrieved. And then what's really cool is, because we're getting down this curation route, is can I just curate data right from my RAG retrieval results? I had this example where I made this Ableton Live, which is a music software RAG demo where I just scraped their site naively and just got a bunch of HTML, and I did the dumb RAG thing and it just worked, right? Then I was like, wow, I'm just wasting so many tokens. Can I just go and write a map where I remove all the HTML, recompute embeddings immediately, and see that my RAG is better, right? All in a sort of much more visual way, where I have all of the powerful retrieval stuff, so it's not just dumb RAG, but I have my eyes on the problem as well. And so that's where we're going with that. It was a half-built thing where I literally wanted to see if somebody would ask me about it, and then we would prioritize it. Yeah, you just did that. So we're going to
I just tried to type a question. Can you help me order pizza or something from the Mosaic Instruct dataset? Super cool. Nikhil, Daniel, thank you so much for coming up. And you guys are building in the open source, but this is a cloud. Who pays for the GPUs? Is this a paid service? How can people, is it a waitlist? Can you tell us more about this part? And then for the open source stuff, how could the community can help and join and give you feedback?
Yeah, absolutely. So I guess the regime that we're in, which we like to say is we're in the small data, big compute regime, right? A lot of these fine-tuning data sets are small, but it takes a lot of compute to compute them. So because of that, we actually want you to own all your data, right? So when you pip install Lilac, it runs on your machine. All your data gets processed and it runs on your own device. And all the compute can run on your device by default. Garden, which is our compute service, is a flag that you'll flip from the UI that will just upload that data to our service, do things like compute clusters or embeddings or PII or Perplexity, and we'll just download them back and throw them out. We do not store data on our servers anywhere. They're just ephemeral for the lifetime of that compute job. And so then you own the results of those clustering algorithms, right? So that's the model that we're working off. I like that because I don't want to own people's data. We're opening this up right now via a waitlist, right? So we have built all of the hard part of this, but we're just trying to figure out the API keys and billing and whatever. So that will be a paid service that you join, you get an API key, and then you'll be able to flip that button from the UI to make it go burr, right? So it is. Sign up for the waitlist. It's on the site. And we are happy to work with people in one-offs because we've been working with folks like LDJ and Austin and Technium. So if you want some high-profile dataset cluster, we're happy to just do it for you.
Yep, for free.
For free, by the way.
That's incredible. And folks, definitely give like a follow. Daniel will add your socials in the show notes as well. Folks, thank you for coming. I really wanted to dive more deep into how people build those data sets. And I think this is for folks on stage who are building data sets, to this free life and post life. And now I can see why. And this is great. So thank you for coming. And we'll definitely release this in the podcast as well. I'll send you guys the link to that. And now a conversation with Eugene, aka Pico Creator from RWKV. In addition to this, we had two sections, so they're kind of cut together before Eugene hopped on and then as he hopped on. So enjoy. In additional semi-breaking news, but from the tradition of talking about the things that we have the authors for, I want to chat about RWKV, the Eagle 7B a little bit. And I want to welcome, where's my friend Eugene? He was on stage just before. Let's see. Oh, looks like maybe we lost him. All right, so let me briefly mention RWKV, the model. However, there's the transformers that we all know and love, and many of the models that we talk about are based on the transformers architecture. And there's quite a few architectures that are trying to break the quadratic attention problem with transformers. RWKV is one of them, based on, I want to say RNN. I see Luigi, you want to do this intro? I think you introduced me to RWKV.
Yeah, sure. I think you're actually giving a decent explanation, but yeah, I would mostly say it solves it strives to try and solve the quadratic scaling problem of every time you double the context length, usually in transformers, you end up doing something like 4xing multiplying by 4 the amount of memory you're using and the amount of slowdown you're causing. And that's what things like Mamba and Hyena and RetNet and RWKV are all trying to solve in different ways. And the RWKV originally started actually from being inspired from a paper by Apple back in, I think, 2020 or 2021 called Attention Free Transformer. And then since then, this guy named Blink DL, a guy named Blink DL has just been working on this with a bunch of other people and upgrading and changing and modifying things for years now, all the way up to this point. Now they're on RWKV5.
So this latest release from RWKV is called Eagle. It's a 7B model, and apparently it's quite performant. However, there's also a demo. I played with it, and I gotta say, Nista, go ahead. I think you have a comment as well.
Yeah, I think it's important to keep in mind it's not trained for as much as something like Mistral probably was. I think it's probably most fair I think this one's only trained for 1 trillion tokens. So I think the most fair comparison would actually be Llama 1 7B. And then once it gets to 2 trillion tokens, then it would be fair to compare against Llama 2 7B, etc. Yeah, so it's like hard to exactly be able to compare, but it looks like it's probably scales well.
I used the previous version a lot, and it did feel faster. Also, I want to say now RWKV has been part of the Linux Foundation for a few months. So again, just because it doesn't feel or doesn't reason as well as a Mistral model, which has yet to be proven, does not mean that this is not going to be useful. Because it scales so well at larger contexts, it might actually perform better there, where, for example, you just dump in a whole book or a whole code base or just dump in like 300,000 words or whatever. So it has a lot of potential in that regard for those uses. I have yet to test how it runs on CPU, so that might be useful there as well. But again, it's super interesting because it's not really the usual transformer-based one, and it has been around for a while. And it goes to say that the transformers are not a dead end, and we're going to see a lot more improvements coming just from architecture changes.
Yeah, so we definitely want more improvements for architecture changes. Definitely, we've talked about the Hyena architecture from Together. We've talked about Mamba, the space state models. I think I mentioned this tidbit before, but I got a brief chance to meet and take a picture with Jan LeCun in Europe's. And the only thing that I could come up with, I literally had a minute there, is to ask him about like state space models, and just the meh that Jan LeCun gave me. It was really funny, like a very specific meh about state space models. And then he said something about we're working, and there have been continuous attempts at like changing transformers. We're still not there in terms of completely being able to replace, but a very interesting area of research, and some combination probably between transformer like attention based stuff and the infinite complex lengths with RNNs could be very interesting. Eugene, I want to just introduce you properly. Welcome to the stage. And this is your first time here. I don't remember seeing you at least on stage here. Please feel free to introduce yourself briefly, and then let's give a brief introduction of RWKV as a concept, but also as a model. Would that be okay?
Yeah, sure. I'm Eugene. I go by the handle Pico Creator. My background was that I got dragged into AI because I worked on GPU.js, and I was a student at the time and the idea was to run JavaScript on the GPU. It was a meme, but it was once only useful thing was matrix multiplication, and I got dragged into AI because it got integrated to brain.js. So like around 8 years ago, all of a sudden my project became the backbone for running AI models, neural network models on the internet. And that's how I got dragged into AI. And since then, I've been involved in the AI scene until one thing led to another. And now I'm jointly in charge of the RWKV project, together with the original creator, Bling Liao. And what's exciting about the RWKV project is that it's a linear transformer and it's attention-free. It represents a threat or potential replacement to all your existing AI models today, because our goal is to scale this up and replace them with something that is 10 to 100x cheaper, that can run potentially on any device. And AI is extremely expensive to run, and like a lot of people know, and we are trying to drastically bring down that cost on the technical side. On the non-technical side, because this is an open source project under Linux Foundation, Apache 2 license, no funny gotchas, with a multinational team, we take a very multilingual approach first. Even if it means hurting our English evals, we care about this model being able to be used by our moms, our grandparents, and in a lot of cases, that means no English.
Yeah, you mentioned like quite a bunch of stuff here, and a lot of this I feel like deserves like a full conversation. But let's focus on the no attention kind of transformers replacement. Like we've mentioned before, but let's just repeat this again. RWKV, this is I want to say 5th version. You also had like multiple models before, like smaller ones. You're focused on making them larger. Are we there yet? What's preventing from RWKV to replace all the models that are now trained on transformers? What are the shortfalls of this technology still as we see it today after you released Eagle?
So we are still benchmarking Eagle now, and the paper should be out like by the end of the month. I think the biggest shortfall right now is that it has not been trained on 40B or 70B, and that's just purely a monetary and compute problem. We will gladly train at those sizes if someone's willing to throw us a compute.
I see. Shout out in the audience if anybody's listening and I've seen this happen on ThursdAI multiple times. If you have compute to give or you're pending compute, definitely this is a very worth pursuit, because the benefits are incredible. The benefits on context length, right? You can walk me through some of the other stuff. 100 times cheaper potentially, running on CPU, running on local, all of the stuff that we talked about, that people are squeezing transformers, performance out of transformers, they come by default because of this architecture?
Correct. Yeah, some folks like to frame it as infinite context. I like to frame it as infinite context like a human. For example, I've forgotten what I eaten yesterday's breakfast. So the model doesn't actually have a real context size limit. It's just that past a certain point, it will start to decide things to forget, just like us humans. And in that case, some people in our team actually argue this might be the better path towards AGI if that's the goal of the community as large, because it mimics those behavior. it will retain memories on things that's close. It can retain memories, and this is something that we want to benchmark, especially with the needle in the haystack with a fine tune, is that it can retain key memories indefinitely. And ultimately, when it comes to unimportant things, it just chooses to forget them.
Wait, Eugene, so I have a question then. Let's say I run it on CPU and whatever the performance we get. On the current Eagle, would I be able to, so first question, would I be able to just dump half a book in there or a whole code base with, let's say, 50,000 or 100,000 tokens? And my other question would be around how much, see that, for example, for Yarn 128K, it uses up about 1 megabyte per token of context. So 100,000 K in context would be 100 gigs. What is that like with Eagle?
For Eagle, you can view it from the lens similar to RNN. It has a 40 megabytes of internal state space memory. How much is stored inside that internal state space is something that we are testing right now. One of the biggest challenges in testing this kind of situation is that, for example, if that book was in the training data, it takes almost no space to store it inside the model because it's already part of the training data. So we are actually coming up with, we are going to do the needle in the haystack test and other tests, but the state space is essentially the brain that stores all the information. And this is what translates into much lower VRAM. As you mentioned, transformer, because that scales per context size. In concept, you could run this on a low-end GPU and just process one token at a time in worst case scenario. And your overhead will be just the model weight, that 40 megabytes, and maybe a few hundred megabytes because it's still in Python and there's inefficiencies. So it's very lightweight in the worst case scenario in terms of if you want to do it at the RAM minimum. That being said, most people don't run it at the minimum setting. We trade some VRAM for speed, and that's where we sometimes call that it runs in transformer mode. So it processes information in, let's say, 1K or 2K chunks. And to answer your earlier question, can it handle a large book? Currently, based on our early experiments, is that yes, the model will more than happy ingest the content and try to understand it and try to answer it. But in the very same spirit of, if I were to randomly read you the entire Wikipedia without explaining why I'm reading it to you, it goes into a void sometimes. So that's why for the needle and the haystack test, we actually have to ask the question first. Hey, I'm going to provide you this book. Please answer this question. And then ask, and at the end, ask it to answer the question again. And we found that works much better because now as it reads the book, it tries to extract out that point accordingly and stores it into memory.
Awesome. Thank you.
Thank you. Some major alpha being dropped here.
We have to dive deeper into this. Eugene, thank you for joining us. We need to cover what happens after transformers. You mentioned Linux Foundation is part of this. Could you speak more about this?
Yeah, so we are the first open source AI model under the Linux Foundation. So that means us as a community, we threw away the lock and key and for the license. That means it will stay Apache 2. This is a direct jab to close AI. That's why we call them internally. You don't need a complex organization structure. You can just take what's existing and to effectively ensure that your model stays open source.
This is awesome. We love talking about open source. We love highlighting open source projects here. A bunch of people also on the RWKV stuff, right? Like this works, if I'm not mistaken, please correct me, but like folks from Luther, I saw Stella Biderman is part of this effort as well to some extent, right? There's a lot of folks that are working on the goodness here, and you guys are like doing the Lord's work, if you will. Thank you for that. If you want to shout out some folks, feel free. And also how the community can get involved and help you.
Yeah, come to our Discord. There's always a lot of work to be done on the inference or training library stuff. Like, for example, we don't really have the trainer working for TPU. I know someone's working on it, almost finished, but like we have a much smaller community than Transformers. So there's actually a lot of things that is on the table to improve on that just isn't the focus of the core team. Even, for example, non-language models, audio models is a potential angle. A shout out I wanted to do specifically was I wanted to shout out to the other Eagle. When we launched over the weekend, we weren't the only Eagle that came out. There was a paper regarding speculative decoding, that Eagle decoding, works on both transformers and also potentially RFQB that can speed up your inference by 3 times.
Wow.
So it'll be interesting when we integrate that together so we have a double ego.
Double ego. I love it. All right. When you integrate, please come back and let's talk about this, because we've talked about speculative decoding multiple times. We talked about inference improving techniques multiple times. Eugene, always welcome here. It's great that we've recovered after the Wi-Fi issues. Thank you for coming up. And folks who want to get involved, there's so much work to do. But as you heard, it's fully open source. They threw away the key. It's under Linux Foundation right now. If this succeeds, when this succeeds, you choose one of them. This is potentially like 100x cheaper to run with less attention, and really incredible effort so far, and definitely worthwhile to pursue and replace whatever we have. So thank you, Eugene, for joining us.